Firstly, let me go to Kaustubh and set this perspective of we talk about industry home and making everything more and more efficient. From your perspective, when we talk about two-wheeler industry or three-wheeler industry, we talk about electric vehicle, bringing it more efficient. From whatever you've seen, are we really reaching there? Are we really having those numbers? Are we looking at some matrices in larger, maybe larger world perspective? Everybody is interested more in India perspective. That's so your target is India. So maybe you can talk more on that.
So we are all engineers, so let me put some data points so that gives a context. The Petroleum Planning Analysis Cell in India reported that 62% of the petrol consumption in India is done by two-wheelers. So if you see the data point for FY24, we consume 37.2 million tons of petrol, which would translate roughly 49.6 billion liters. If you do a broad math, right, assuming 270 million petrol two-wheelers available, it would be 140 liters per two-wheeler per year as a consumption point. So if we are talking from an electric vehicle point or an energy point, typically a two-wheeler would consume 140, which could be replaced by 152 kilowatt of electricity. So it's not just having electric, having alternate fuel or any other fuel. It's something what we are consuming, what we are emitting, and how green overall the cities become, how quieter the cities become, and how efficient the vehicles or even the entire transportation becomes. So there's the first part of the problem. Second is when we talk about EV, it's definitely reducing a lot of parts from a conventional IC engine perspective. However, when we do the math, we see the hardware is reducing, like the metal part, the plastic parts, or the moving parts getting reduced. However, a lot of electronic gets added. And today, electronic, we are still trying to reach there. In the earlier conversation, the speaker mentioned that the innovation is already there. We are not reinventing, but the application layer is still to be built, and still it's a distance. So this is a larger problem. How self-reliant we will, how locally we are able to produce, and how better way we are able to meet the local demand, and local will drive the circular economy, which will in turn be sustainable. Otherwise, the supply chains become so complex, where you have lead times over 52 weeks. You need to pay today and get delivery after 52 weeks, and that's also not assured. So those kind of challenges throw up. So it's an ecosystem problem. It's not a product problem or a process problem. So we have to see it from an ecosystem perspective. Largely, at Imoto, we are trying to solve that. And happy to answer more on this.
Okay. So, in a nutshell, you're saying that this circular economy is the direction that we should take. The individual components coming together in the electric vehicle definitely, and I would like to make that statement that life has become simpler as you get into from ICE, where there were 20,000 kind of components, moving components, to electric vehicle where you have 2,000 components. It's very simple, right?
So let me not answer directly, but maybe indirectly. Mobiles and laptops were invented to make work easier. So today, if you see mobiles and laptops are just limited to work, or they are being consumed for many other things. It's the same way how we are trying to address the EV versus the ICE problem.
So in a nutshell, it is extremely complex. Wherever you are talking about a simple battery management system, you have motor controller, everything as a logic is embedded, it's prepared, it's kind of a software system that you have there where you have to do it earlier than you do it in physical ways in ICE vehicles.
Precisely. See, a McKinsey report states by 2030 or 2035, 70% of the cost will come from electronics and software. Largely the plastics and other metal parts will be commoditized, but the premium will be on the electronic and the software. And that would govern the vehicle cost as well as the performance.
Wonderful. So let's go to Yogesh and check on him for eventually the products get complex. Right? You want to make it more efficient. It becomes more data centric. Where data is important for manufacturing as well as product, like product being intelligent into the market, and you try to make it connected, and you would have use cases where you want to be making it more efficient, right? Maybe those insurance use cases, something that you have been dwelling with. For eventually reaching the sustainability part, you can give your perspective. I'll just start from where Kaustubh really give a good perspective on the technologies on right from the engines to the electric now, while also moving back to the hydrogen as alternate options overall, and coming from the powertrain journey, which we've seen right when you're still trying to make that engine uh, making the lives longer. Okay, so still the circle is coming from engine to electric to back to engine again with the hydrogen as a alternate option, making it more greener technology. Because in my language, I used to say that we are used to eating like this. With the electric, we are kind of trying to eat like this. So you are generating more energy, a more carbon footprint in having the same thing to do. Essentially, that's one of the thought process. And then coming back to the when I moved from now the powertrain world or engine world, the battery electric, then as he said, a lot of components have become smaller, but then a lot of electronics content. There's a lot of the recyclability, or obviously everybody is talking about a battery being the finite sources, the kind of the mining related issues which we have. Then also the question on the lot of battery waste or electronic waste, right? And then one of the technologies, I would give you one of the example is how the technologies are helping towards making it still a sustainable option or towards sustainability option. So for a battery, when I used to work with the BMS or battery companies, the AI is enabling those batteries to track its behavior to ensure that it's still operating at a most operating and most performance point as well as the safer point, so that they don't degrade faster. So you are trying to make sure that life is longer, which is again the sustainability angle. The other angle is the safety, and that's where the AI try to ensure that not the battery is not just efficient, stay longer during its automotive operation, but also it's for a second life. So there is a battery pass kind of a technology which will continue looking at and ensuring that that particular battery being utilized in multiple second and even third life use cases, and ensuring that I'm able to extract those battery materials again into recycle situations. That's an example on the electric batteries and electric vehicle. The coming to the where I moved from powertrain to the connected vehicle, where we do see that in the vehicle operation, right? How we can ensure now you see that in the day-to-day operation with our traffic situation, there's a lot of carbon, or I mean, you're consuming a lot of fuel and ultimately you are generating a lot of carbon, right? So how you ensure during your complete point A to point B movement, how you can make it much more fuel efficient that journey, right? So one is the option of in the connected vehicle where the technologies or the AI or vehicle telematics unit tracks the driver behavior, saying that okay, you are doing sudden acceleration, sudden braking. Okay, so how that live driver tracking and giving him recommendations, saying that hey, you need to drive at this speed or that speed, and also there are a lot of controls are coming where you don't need to do much. The vehicle will itself take a better control and ensure that you are operating at a best efficient point, fuel efficient point, and hence carbon sustainability you are bringing in. That's the second example. The third example is also now vehicle will give you recommendation that when you are traveling from Mumbai to let's say Pune, right from this part of the east to the end part of the Mumbai, when you are traveling your journey, there are a lot of signals where you stop, right? And the moment you stop from
that red to green, you are still keeping your either engine or battery consuming more energy and hence more carbon, right? So there are technologies which are being given that it maps out the whole journey. We call it as a V2I, where vehicle connects to the traffic signals, and they know that at what time these traffic signals are going to go from green to red, and at what speed you are driving. So it will give you a recommendation that hey, go instead of 30, if you go 40, you will be able to pass that signal, and you are saving this much of fuel, but it will directly give you the indication of how much of the CO2 you are able to save it back. And then there are a lot of this kind of a driver monitoring, driver coaching, and the technologies are enabling it to make it more sustainable during your vehicle lifetime operations. Wonderful.
So, what I hear from you is beyond being just manufacturing of components like battery or a complete vehicle, how its utilization to make it more energy efficient rather than just talking about electricity or whatever is the energy that you're looking at, how to make it more efficient, right? That's the way we have to look at sustainability.
Yeah, so I would call it as a now holistic approach. Yeah, overall product life cycle. Now you know that now OEMs are not just looking at, earlier they were looking at until the end point of the sale. Once the sale has happened, now maybe until the next 3 years of the warranty period, I will take care. But beyond that, then there was none of the thing thought process was there. Now they are looking at the whole product life cycle, and given the government push for using recycled materials also, that has pushed them to look at end-to-end customer to customer kind of a life cycle essentially. So that's the product life cycle, not just design manufacturing, it's total life cycle operation level, how I can manage that efficiently and make it more sustainable both for themselves, and they are able to extract good amount of data, and there is a lot of use cases being built up on the data to monetize during the life cycle also. So they are trying to say that how do I generate a money or dollar, not just by selling it, but beyond the sale point as well.
I think there is some kind of business secret you're trying to get out. We actually, before discussion, we decided that we will not talk about one. EV is a green solution or not, or is hybrid somewhere. That was one point that we decided that we will not bring that debate. And the second point is that we will not talk about government supporting, not supporting policies within that. But I think the sustainability element is coming out very, drastically. I think let's go to Gururaj for his perspective on, aspects of simulation, right? We talk about digital twin, bringing simulation of manufacturing process ahead of time. Utilization is very important. Overall, your equipment effectiveness (OEE) comes extremely critical. So, in the perspective of using these high-end tools, right? Do you see those sustainability matrices like carbon footprint, carbon credits, energy footprint, creation of carbon dioxide, carbon monoxide? How does that tally to something that you are talking more about, digital twin, or the latest concepts? Would be a kind of open question for you.
Sure. Thank you, Shirish. Thank you for this opportunity. Okay, now let me start off. I mean, that's an interesting question as to how digitalization would actually support all of this. So let me just step back and then go through quickly what are the stages that happens before we get onto the shop floor, and how a digitalization could help. Starting from your manufacturing strategy itself, that starts with your make and buy decision. Can you quickly simulate what if I were to take a different part with a different material coming from different suppliers and quickly roll it up and see what is that I'm going to contribute towards CO2. That's a first, and that's even before we get into the actual planning part. So that's a first stage where we start with the manufacturing strategy where we can simulate and see what is the most optimum product combination, and then how much are we contributing towards the CO2.
Basically, baseline, baseline where you are.
Looking at all the suppliers. So when you talk about suppliers, we're also talking about the logistics that's involved. It's not just about supplier giving you the end product. It is about that particular part reaching to your line or a station. What is it you're actually contributing towards CO2 depending upon what kind of logistics you use. So you should be able to simulate that, and with our digitalization tools, you could do that. Then once when you're done with your strategy, then you come to the stage of how you want to assemble this product. How should be your plant? What should the plant level? Typically, when you're starting a green field, then it's open for you. You can go ahead and design. What about a brown field plant? What are the changes that you need to make? So you need to start with digitalization of that one, simulating how the plant would work, okay, in terms of material movement, in terms of AGVs, and also all those things. So that's the second part. The third one comes the production planning, and this is again the most critical one because you have to respect the just-in-time, look at the just-in-time part of it. Your suppliers, are they co-located or are they coming from different places? Simulating all of that using digital logistics will help you that and it help you to plan. Now, when you talk about production planning, it is actually in real time looking at the resources status at that particular moment. Beginning of the shift, you look at what the status of your plant, and then you do your scheduling, production planning and scheduling. Once when it is done, you get to the actual execution part of it. And as you're executing, you are then starting to record what you're executing digitally and also monitoring how is your line performing because you have a certain output that you're expecting. You have your takt time. Are we doing all right on that? Now, when you talk about production planning, let me just go back to one step again. Typically, we have been talking about line-based assembly. One of the things that's coming out or emerging is the cell-based assembly for automotive. We have not heard of it, but it's slowly coming up because that's going to be the most optimal way of doing it, where you consume less resources and then your output is going to be much more higher. So that comes to the production execution part of it. Then comes, while you're executing this, then comes the monitoring. How are your resources working? Now today what we're doing is we are probably taking at the end of the shift. Now with digitalization, you actually get the data in real time and then take action in real time. How is that resource doing? And you set certain limits, and as soon as that particular crosses that limit, then there's an alarm or a notification comes to the line manager, whoever it is, he takes action. So your resources are not going outside the threshold that is already been set. That's one thing. Then finally you start optimizing. So here again you come to the digitalization aspect, how we can optimize your entire production.
So the whole thing as a cycle that is available for doing all this possibility of parametric analysis, simulating it before you really get into that investment.
So you can do all those analysis upfront on possible combinations or your resources based on some historical data. See, one is you do a simulation upfront, that is as part of the planning part, which is what we do in the initial stages. But as you start running the plant, you have to feed it back into the simulation model, which is what we call it as a factory twin or a digital twin of the production. So it starts feeding back into the simulation model, so you get it in real time. You'll see that in real time. And what we have as the latest technology is the industrial metaverse, where you can actually see the photorealistic rendering of your plant in a digital way, including its operation in real time. Like, for example, there is a machine that's doing mixing. For example, if it's a battery plant, there's a machine that does the mixing part of it. You can actually see that mixing in real time, which is actually getting simulated, and you take action on it. So that is how digitalization will help you to initially plan, optimize it, and then further, as you start going through the production,
right. So it's end-to-end before you conceptualize, where you are able to get the resources, look at them, arrange them, try them, eventually get to the reality and optimize them eventually. I'm seeing that these 7 ways that Lean gives, you're able to kind of extract them and get that best of the best for making it more sustainable, more efficient.
That's
right. So let's move on to Sanjay, bringing the most important portion of automation, right, is key to the world where things really matter, right? Those controls are so critical when you get the data from those source, and it is source of truth, right, where things, those speeds, those temperatures, those pressure. So how do you think that automation enables these dimensions as sustainability?
Yeah. First of all, thank you, Shirish, for the opportunity. And as you said, automation is sort of a foundation to build our IoT story and further sustainability on that. So it starts with right from basic sensing of it, sensing the data, monitoring the data, and then taking some informative action. So for say any information software or anything, he has to build any dashboard, or he has to take any corrective action, say anything, if say we are monitoring a predictive data, and if proactively we need to inform anything related to operations or any, so the right tracking of that particular data and taking informative action is very critical. And as you said, because automation is something which will cover the entire aspects of the sustainability, because when we talk about sustainability, it talks about the process improvement part, it talks about the waste reduction, it talks about how we can optimize the energy consumption, it talks about how we can reduce the overall consumption, or is there any means of say to use the equivalent, I will say, optimal fuel and all. So from that point of view, automation will play a crucial role. And once the data is captured properly, then it can be processed and the corrective action can be taken on that.
Super. So, shop floor to top floor kind of a view that you would be able to generate. And I see, Toyota talks about something called as Gemba. Gemba is where you be there where things are happening, right? You be physically present is what's recommended by Toyota management system, but being virtually present, that the way that we spoke about is happening for automation, simulation, product development, all through the life cycle. I will go quickly around for at least one success story from each one of you, and then we will open it for questions. I would ask Kaustubh, any kind of quick success story that you would like to highlight?
Largely, right now we are not in India, but largely we are in Indonesia.
May you compare it with any other two-wheelers?
Sure.
May not be your own.
Sure. But success stories, the adoptions in Indonesia has been immense. Like we are getting positive review. So Indonesia is still 3 years behind the electric vehicle adoption curve from Indian.
So India has 4 to 5%.
Still high.
Okay, so we should be proud.
We should be proud.
Okay.
And actually, India has an opportunity to play a larger role in this ecosystem and the product development perspective, because our neighbor is interested in the car industry. We are in the two-wheeler space, so we can lead the way. So largely in Indonesia, we could tap in the best of both worlds,
okay,
and create a solution which is unique to Indonesia, and take it forward from there.
Okay, Yogesh, from your point of view. And there are enough questions, right? There is a lot of knowledge on the stage. So you have questions, otherwise we'll continue for a while. You have questions, right? Okay.
Just quickly, two major data points coming from a connected vehicle where I'm engaged with this Valtech mobility Volkswagen joint venture. So we have you can see on the cloud platform where the data gets collected from the vehicle or telematics or infotainment device to the cloud, and then it goes to your app where you can use different services or features which you call it. So the main data point here is the cloud platform where the data goes. So there's a lot of carbon is generated. Each call when you use your feature on the car app, right? That each call makes 1 gram of carbon. Okay, forget about the data cost there. Across OEM now, every car is getting connected, and there's a lot of data cost is coming. There's a lot of carbon footprint. So on the cloud platform, we are managing 35 million vehicles in 65 countries with 370 plus variants. So it's a group, Volkswagen group covering Porsche, Bentley, Lamborghini, MAN, Seat, Skoda. You can see 11 group, and then per day, literally 10,000 vehicles get added. You can imagine the kind of the data getting pushed from vehicle to the app through the cloud, and the transactions and the amount of carbon. So we have been able to manage the cloud platform. I won't be able to directly give that, but we will be definitely good amount of tons, I can be sure of. The key success story is how you manage your cloud platform in a way where there's with one call there's a minimum kind of energy goes and minimum carbon footprint that comes out. That's one of the major success stories. And obviously, as I said, a couple of stories on driver efficiencies and so on.
So maybe okay. That's wonderful to get the monetization or the numbers coming directly in the metrics form. Gururaj,
Yeah, okay. One of the examples that I can quote or I can share here without naming that OEM, it's not OEM, okay? It was all about helping them optimize their overall production scheduling in real time, where they had multiple plants, and raw material was obviously coming from one outside and also some internal production. So this entire from plant to line to line that was virtually simulated, and then whatever were the bottlenecks, one loss of energy, loss of time, production was all eliminated with this entirely through the digitalization process, simulating it in real time, and they're reaping the benefits of it.
super. Sanjay, from your point of view?
Yeah. So I'll just share one example that we work with one of the process equipment manufacturer, and they were into this single-use reactor, which is kind of upcoming technology now. So just by deploying the solution with the approach of basic philosophies like adapting to ES88 standards and capturing all the right information, we could commission the equipment in very limited time. Also, we could save the wastages, because particularly in a bioreactor kind of application, if your parameters are not tuned, then after you complete the batch, you come to know whether the product is right or not. Yeah. So that really helped us to avoid those kind of rejection, and of course it has helped with the consistency in the product.
I think we can go for questions. We'll summarize later, but I think we can go for questions.
Please raise your hands. Thank you. It's really wonderful session and being here today. So I have a question. See, since morning we are talking about manufacturing, digitalization, ESG, EV, and India as a manufacturing hub for a global. Right now, if we see past data, there are still vehicles of petrol, diesel. Now we are into EV. But however, in US or Europe, they already started talking about the hydrogen vehicle. So, what is your opinion on that?
I would say it is out of context of this uh, panel discussion, but I'll give you my perspective and others also can contribute. Very briefly, hydrogen is still on the horizon, is what I
Yeah,
would
but
say.
still there are, if you see in US manufacturing already
It's
started there.
It will land in India also.
Yeah, it is landed in India also. So considering he is talking about carbon
See, there are
footprint.
challenges. If you have finished.
Yeah, let me complete. So he is talking about the carbon footprints and if we see EV
Okay.
and hydrogen vehicle, if in future globe adopt that hydrogen vehicle, so how it will be affect to environment and other part of the.
So I'll give you one perspective. Hydrogen is used in two ways for a vehicle. One is directly using it as a fuel. Second is to basically convert water into hydrogen to generate electricity. And electricity is getting actually driving electric vehicle, which is still having its own efficiency.
Okay.
In conversion of hydrogen, efficiency of conversion of energy for hydrogen is around 22%. It's extremely not efficient. Technology for hydrogen is still on the horizon. Carrying of hydrogen across 800 bar, right, with a thickness of couple of inches of to carry it as a cylinder across as a distribution channel, we are still not successful in CNG.
You're right.
So these are some perspective. I will tell it is a controversial topic. I'll have Yogesh to give. I'll have Kaustubh to give some perspective. But that would be something that we'll be humbly stopping there.
No problem.
Yeah. So my only submission would be, we are currently in a transition economy. So everything is transient, nothing fixed. Right now the world is trying to move away from crude. So there will be multiple options. It could be multiple alternate fuels. Today we are talking about hydrogen EV because technology has reached to certain maturation level. That's why those applications are seen. Tomorrow maybe completely different fuel which will come up. As technology matures, as adoption improves, things will move. So today, the best part is to be in the transient economy, try and experiment larger things, and be a part of the game rather than be on the fence and try to evaluate what is there, what will go wrong or what will go right. Major time is to experiment and bring products to the market or contribute to the ESG journey or the sustainability journey. That would be my take. So there is no right or wrong answer, so to say. It's basically how you take it forward.
Yes, it's not right or wrong, but it's just a.
First of all, thanks MOTOTECH for this session. My question is, may we are only seeing the digitalization, but whenever you are working with the most of the MSME, there is no digitalization because they have a traditional presses, traditional lathes, or so how these people will get digitalized and that they will contribute to the nation for the sustainability?
Wonderful question, and I would have others also to contribute, but maturity of industry even 4.0 for if you take MSME is around less than 1%, scale of 5, 1, less than 1. If you take mid-sized companies also, it's around 2.53. We're talking about 5.0, which is on the horizon, but still not arrived. It's there in the Europe, and we are trying to pioneer it in 5.0 because it brings a larger perspective of ESG, becoming governance and also business strategy, which is most important for operations to become more efficient, but not blindly, but with a perspective of larger view of sustainability of something called as larger society 5.0. That's where it is. MSME have to mature. So if at all it is required to be having an awareness drive, those have to be driven. If at all it has to be some very basic tools like Excel-based tools or Tally-based automation, that could be done for MSMEs. They have to be done. And eventually you should look at the bigger picture that this is where we have to move. That's kind of a 3 to 5 years roadmap that you should draw. Anybody wants to add?
One interesting perspective I would share. So any technology, if you see, has an adoption curve. So if you see laptops, it took 23 years to reach a saturation level of around 80% as a penetration. If we compare laptops with handphones took around 16 years. EVs, it is estimated 6 to 7 years, and as technologies improve, as things are available, the adoption rate should be much more faster. Same, if you see it in parlance, the story goes for, say, the e-commerce, now we are seeing it in the quick commerce and all. Something similar will have to be applied to the SMEs and MSMEs. So how adaptable they are in adopting the newer technologies and newer solutions will facilitate them to join the league of getting into the ESG or the sustainability story. Otherwise, they will be sidelined or marginalized.
One point on this one is on the maturity, what Shirish mentioned. So when you look at maturity, it's not just about digitalizing, it's about the process maturity itself and the people maturity. Because we also need to upskill the existing workforce to be able to start using digital tools so that you can see the benefit. If that doesn't happen, if you just go ahead and digitalize your processes, you won't get the benefit. You will not see that what you're expecting. So it's very important to look at the digital maturity of the organization across all of these people, process, technology, integrations, and so on and so forth. And then we will have a roadmap where we can move from one, as you mentioned in the MSME segment, it's probably less than 1. We can go up to 4, 3 to 4. That could be an aspirational plan.
I think let me conclude this session. Wonderful insights by the speakers here. In a nutshell, we are on the journey, right? 4.0 is going to be there. We're still not there. 5.0 is on the horizon. We'll keep talking about it. We'll make it more popular where it starts getting adopted at the corporate levels, at least where it touches for MSMEs in that larger picture, where sustainability metrics, as we create in a click of a button, if we're able to get the carbon footprint, nothing like it, the best way that we can leverage the technology, the way that we can get the simulations into the place where before we commit to something as resources, I mean, the manufacturing line costs huge, right? If you are able to get those resources ahead of time, are able to simulate them and get the best of the best optimized, that is the key to success. I think automation is the key to success where it matters of getting things together and getting those matrices from shop floor to top floor view is key. I believe, thank you very much to all the guests and we'll have more sessions. Thank you.